In this video, we are going to look at how light is involved in seeing things around us and in the formation of images in a mirror. So let me define the basic things. Right, we'll start with light sources. Primary light sources. Primary light sources are sources that emit their own light, such as the sun, the candle, bulb, fire, etc. We can divide primary sources into two types. One is a point source and the other one is an extended source. A point source is a small source. It can be a tiny bulb or a LED, which is very small. So the light from such a source will move out in all directions, as shown in this first diagram. Now, an extended source is actually a collection of a number of point sources. So I have shown an extended source with 5 points marked on it, and each of those 5 points behaves like a point source. That is, each one emits light just like the first diagram in all directions. Right. Now you might be knowing that the light that we talk about is white light. The light from the sun is white light. White light is a combination of several colors. When all the colors combine, it gives white light. By passing a beam of white light through a prism, we can split it into various colors. Normally, the colors of the spectrum, the rainbow colors. So in this diagram, I have shown 4 colors: red, yellow, green, and blue. How it separates when it enters and exits the prism. And this phenomenon of white light splitting into different colors is called dispersion. Right, now primary sources emit their own light, but there are other objects around us which are visible to us. They all reflect light that comes from the primary source. It could be a bulb, or it could be the sun or moon or whatever. So all visible objects reflect the light falling on them. Okay, I'm going to pose 2 questions. One is, there's a black color object. Can you see a black object? The second question is, can you see the surface of a clean mirror? A mirror which is not dusty, a clean mirror. Can you see the surface? Right, you think about this question before you move on. Right. Now when you look around us, you see objects of different colors: red, blue, green, yellow, orange, all kinds of colors. why do they appear different colors? The light from the sun is white, is called white light. So that's the light that is falling on all these objects. So a red color object, why is it red? The reason is, when white light falls on it, white is a combination of several colors, the object absorbs all the colors and reflects only red color. So you see the object as red. Same with green and blue. Right, now the question, now here is a black object and white light is falling on the black object. What color light is emitted from the black object? Black, as you may be knowing, does not emit or reflect any of the colors, any light. That is why it's black. So black is not actually a color. It is the absence of a color. When there is no light involved, when there is no light around, everything will be black. If you shut your eye, or if you close all the doors and windows of your room and draw the curtains and switch off the lights, your room will be pitch dark. What you see is black. Okay, now we have a white surface, a blank sheet of white paper. Light falls on it, white light falls on it, and the white paper reflects all the colors. Therefore, it appears white. Right, I posed another question. Can you see the surface of a clean, plain mirror? The mirror you use when you are doing your makeup. If you look closely, you will realize that the surface of a plain mirror is not visible at all, unless there is some kind of stain or dust attached to it. If you can see the surface, it means that your mirror is dusty and needs to be cleaned. So let's think why it is that you can't see the surface of a plain mirror. Okay, that brings us to two kinds of reflection. Right? The first diagram shows a plain mirror, and the second diagram is the surface of a table or a book or whatever. And in both cases, a parallel beam of light is falling on the surface. The plain mirror is reflecting the three rays that I have shown, in such a way that the three rays are parallel. Now the second diagram, the three rays I have drawn, where it strikes the surface, lots of new rays emerge. One ray is split into a number of rays which travel in all directions from every point. This is called scattering. The beam of light falling on the ordinary surface is scattered in all directions. That is the clue to understanding why a mirror surface cannot be seen. Right, now let's see. What is involved in seeing an object? Most objects scatter the light falling on the surface. A mirror does not scatter the light falling on it. A narrow beam scatters into hundreds of small rays going out in all directions. I have shown it in the diagram. Right, now let's see how the eye is involved in seeing an object. We'll consider a small object. I call it O. Right, this object, to be visible, has to be illuminated. That is, the light from the sun or the bulb should fall on it and it will reflect in all directions. It will scatter the light that is falling on it. Now our eyes have a lens. Now from this object a cone of light is falling on the lens, eye lens, and the lens, what does it do? It focuses that light onto the retina of our eyes. So that is, it creates an image of the object on the retina. Right, and the retina has lots of nerve endings which connect with the brain, and when the nerve endings are stimulated, the brain recognizes the object from the past knowledge. Right, to see an object, cones of light from every point on its surface must fall on the eye and be brought to a focus on the retina. For this to happen, every point of the object should scatter the light falling on it. Right, now here's another important question. Now you're looking at an object. It's out there in space. Do you see an object exactly where it is? Or can you see, are there occasions where you see an object in a different place, different to where it is actually located? If you look at the two diagrams I have shown, you will see in the first diagram a straight cone of light from the object falls on the eye. In the second diagram, a curved cone, a cone which is curved for some reason, falls on the eye. And when you extend the rays that fall on the eye, they converge at eye. So the light that falls on the eye appears to be coming from eye. So even though the light is coming from object O, object at O, what we see the image of the object, we see the object at eye, at a different place. That is because light has curved. This can happen in certain instances when there is, on a hot day, due to changes in temperature layers of the different layers of air, you can observe this phenomenon. Right, next I am going to look at how an image forms in a plane mirror. Right, so there is a plane mirror A, B, C, D, E, F, and there is an object O above the plane mirror, and I have shown 6 rays of light coming from O and falling on the lens, on the mirror, and getting reflected. And the different rays reflect in different directions according to the laws of reflection. So after reflection, these rays are diverging, are spreading out. But all these rays appear to be coming from a single point, eye, behind the mirror. So if your eye is positioned on one of those cones, you will create an image at eye, which is the tip of the cone. So wherever your eye is, as long as it receives a cone of light, it will create an image at the tip of the cone, which is a single point eye. Right, I have shown in this diagram a less complicated diagram, just two rays of light reflecting on the mirror and falling on the eye, forming a cone, and the tip of the cone is at eye. So the image of the object forms at eye, and you will notice that the distance from the object to the mirror and the distance of the image to the mirror are equal, and the line joining the object and the image is perpendicular to the mirror. Right, now I have given you another example here. Can you try to draw the ray diagram and the image?